Shri Gurubhyo Namaha children. Welcome to our online teaching academy Ekalaiva. Hope you are enjoying your online classes. Today we are going to learn phasor and phasor diagram. So last class I gave you the introduction of alternating current. And I was also telling you that the direction of alternating current changes for every half cycle. So, and we were also discussing about the mean or average value of AC and also RMS value of AC. Okay, how to find out the value of current if the current is alternating. Okay, now the continuation of that is phasor diagram, and also we are going to discuss a 5-mark question which is an AC circuit containing pure resistor. So to start with, let us start with phasor diagram. Phasor diagram for an alternating voltage. So what is phasor? So before we go on to phasor diagram, you need to understand what is phasor. So what is a phasor? A phasor is nothing but a sinusoidal alternating voltage which is represented by a vector. Now an alternating voltage, now this is how an alternating voltage appears. Okay. Now this voltage, this alternating voltage, if it is represented by a vector, okay. Now this vector rotates about the origin. Suppose this is the origin. As far as this diagram is concerned, this is the origin. Now this is a vector. Now this vector is nothing but you call it as a phasor. Now this rotates in the anti-clockwise direction. Suppose let us consider this as the origin. I will just show you how it will be origin, and let me consider a phasor. Now initial position of the phasor will be along the x-axis. This is x-axis and this is y-axis, right? Now the position on, now let me name this as A. Okay. Now the initial position of this will be in this direction. So it starts rotating in the anti-clockwise direction like this. Okay, so this is a phasor and it rotates in the anti-clockwise direction with a velocity omega. Okay, now this velocity is a constant velocity. It's a constant angular velocity. Now this rotating vector is nothing but you call it as a phasor, right? Now we know the voltage equation. What is the voltage, alternating voltage equation? V is equal to Vm sine omega t. Okay. Now let me tell you how to draw this phasor. Okay. Now this is a phasor. Now with this, for taking different values of theta. Now this sine omega t, now this can also be written as theta. So for different values of theta, how to draw a phasor diagram, that is what we are going to discuss next. Okay, so hope you understood what is a phasor. Phasor is nothing but it is a vector which rotates about an anti-clockwise direction. It rotates about its origin in anti-clockwise direction with a constant angular velocity. So this rotating vector is nothing but you call it as a phasor. Now this is a phasor. As far as this diagram is concerned, this is the origin. This is a phasor. Initial position of the phasor will be like this. It starts rotating along this direction for different values of theta. Okay, suppose let us take this as x-axis and this as y-axis once again, children. Now I'll consider a phasor. Okay, now here is a phasor. Now the initial position of the phasor is in this position along the x-axis. So let me take the equation. V is equal to Vm sine omega t. Now let us substitute for omega t. First value of omega t will be 0 or theta is equal to 0. So when theta is equal to 0, what will be the value of voltage? V is equal to substitute sine 0. Okay, so sine 0 is 0. So when you multiply this 0 with Vm, again V is equal to 0. So plot the first point. Now this is omega t, right? This is along the x-axis, it is omega t. Now this is V, right? This is instantaneous voltage. Now for the first position, for theta, now I have origin O. Now what is what one full cycle you have, excuse me children, pi and 2 pi. So I'll start with omega t 0 and voltage 0. So this will be my first point. Let me have a small cross here. Okay. Now second I'm going to take the value of omega t as let me take it as the theta value to be 90 degree. So when I take 90 degree, now this is the initial position 0 0 I have drawn. Now I have taken the phasor to this, and the phasor has reached the angle 90 degree. So this is the position of the phasor now. Now theta is 90. Okay ma. So when omega t is equal to 90 degree, now here sine 90 will be 1. So multiply 1 with Vm. So I have V is equal to Vm. Okay. So in that case, maximum amplitude 90. Pi is here. So 90 will be in between. So I will have a cross here. So this is for 90 degree. Right. Then the next angle we consider quadrant. So the next quadrant is here. From first quadrant is 0 to 90. Then 90. Then again you will have 180 degree. So 180 degree. Substitute theta as 180 in this equation. Sine 180 0. 0 into Vm is 0. So again V is equal to 0. So for 180 this is pi. 180 is pi. So I have a point here. Okay. So theta is 180. Voltage is 0. Okay ma. So here 0. Then take the next value of omega t. Omega t is equal to, what is the next value? Theta will be 270 degree, right? So 270 degree, substitute omega t as 270. So sine 270 is minus 1. Minus 1 into Vm is minus Vm. So V is equal to, here I have minus Vm. So in that case, I will have the value along the negative axis. Now here I have minus Vm. Now here it is 270. Between pi and 2 pi, here I have 270. So I have plotted theta 270 and V is minus Vm, maximum, rather amplitude maximum, right? Then the fifth angle is omega t is equal to 360 degree. So 360 degree, again sine 360 will be 0. 0 into Vm is 0. So again V is equal to 0. So again back to 360. So when I just join all these points, look at the phasor diagram I'm drawing. So this is the phasor diagram for the voltage. V is equal to alternating voltage. So what is a phasor diagram? The diagram which shows various phases. Now here the phasor is initially at 0. Then the phasor goes to, this is rotating in the anti-clockwise direction. Now this is, the angle here is 45 degree, right? So initial 0, then comes to 90, then comes to 180, then comes to 270, again 360. So phasor is rotating in the anti-clockwise direction. For different angles of the position of the phasors, if I draw a graph, now this diagram is nothing but you call it as a phasor diagram. Now this is a question, they may ask a question, what is a phasor diagram? The diagram which shows various phasors and their phase relations is called as phasor diagram. So this is how this diagram we have got. Hope you are able to understand. Now this particular point. Now what is this? Here it is the voltage at this particular point, which is Vm sine omega t. Okay. Now here is the voltage maximum. We have Vm here. Here is instantaneous voltage. So the direction of phasor for different position is drawn, and this is how you draw a phasor diagram. Okay. And we are going to learn some how you should draw a phasor diagram. So here, suppose this is a phasor, right? Now the length of the line segment, now this is the line segment, right? So the length of the line segment gives the peak value. So this is the maximum value of the phasor, which is given as Vm. So what is Vm? Vm represents the peak value of the alternating voltage. What is Vm, children? Peak value of the alternating voltage. Okay, and what is omega? Omega, as I told you, angular velocity, and it is here as far as an alternating voltage is concerned, we talk about angular frequency. So this phasor rotates with a constant angular frequency called omega. So omega is the constant angular frequency of the Now since this graph is for voltage, we talk about alternating voltage. Now the same graph, you can draw same graph for current also. In that case, we'll say it is alternating current. Okay, ma? Right. Next, the projection of phasor. Projection means how the phasor is projected with respect to the x-axis. Now here the projection is in this direction. Suppose here we can consider the phasor to be making an angle of approximately 45 degree. Okay, so the projection of phasor, what angle the phasor makes with the x-axis. Okay, ma? So the projection of phasor on any vertical axis, here this is the direction of the phasor. Now here the phasor is projecting vertically along with the y-axis. Okay, now any point in between this, the projection of phasor on any vertical axis. Okay, suppose if this is reaching a point here, now this is a point, this is a vertical axis, this is a point. Now this point will give the value of the instantaneous value. If you draw a line, you have Vm sine omega t, which is nothing but, this is called as, now this is nothing but instantaneous. Why it is instantaneous? This value is with respect to this point alone. After this, the value will be changing. So this is called as instantaneous value of AC. So the projection of the phasor at any particular point on the vertical axis will give the value of instantaneous value of alternating current or alternating voltage. Now this is alternating voltage, so I will write alternating voltage. Now this applies for current also. Okay, ma? Right. Now what is this angle? Now I am coming to the point what I was telling you. Now this phasor makes an angle with respect to the reference point. Reference point here is with respect to the positive x-axis. Now this omega t is nothing but, you call it as phase. P-H-A-S-E, phase. The angle between the phasor and the axis of reference, okay, indicates the phase of the alternating voltage or alternating current. So why do we use this phasor diagram? This phasor diagram is used to analyze the relationship between voltage and current. Okay, how this voltage and current varies in different AC circuits. To study that, we go for these type of phasor diagrams. Okay, now look at this. Look at this. Now here I have already explained you what is this length OA. Now let me name this as A here. So OA represents the peak value. Okay, OA represents the peak value, which is equal to Vm. I've already explained you the variables here. Vm abindrathu peak value, and what is sine omega t? Sine omega t is the phase. Okay, is the phase, and V gives the instantaneous value at a particular instant. Okay, now this OA rotates about angular velocity in clockwise direction, right? So for one full cycle, when it starts from 0, when it starts from 0 and it keeps on rotating one full complete cycle, this is how the phasor diagram looks like for one complete cycle of a wave. Okay, now listen here. Now here is the phasor and wave diagram for, now this is the phasor diagram for voltage. This only I explained you now. Now here I have P is equal to Vm sine omega t. Now this is for the alternating voltage. Now there is one more graph here in green line. Now here this represents the current. This is for current. Now here the current is leading voltage by a phase angle of phi. Look at the current graph, current diagram here. Now here, this is the phasor, current phasor. Okay, and here is the maximum amplitude of voltage, which is given as V is equal to Vm sin omega t, where Vm is the maximum voltage. That's the length segment OA. But look at the segment of OB, which means the value of current, the peak value of current is lesser than the value of the voltage. So this is the phasor, current phasor, and what is the angle between the voltage and the current phasor is phi. Okay, so what is the total angle in this case? The total angle will be omega t plus psi. So when I write the equation for current, I write as I is equal to Im sine omega t plus psi. So which in this case, the current, what is the relation? What is the phase relation between current and voltage? Here, the current leads the voltage. Look at the value. Now, when we plot the value of voltage, we plot with respect to origin. Initially, omega t 0, V is also 0, but it is not the case as far as current is concerned. The current leads voltage by what is a value, what is a phase value is phi. So we can say that this phasor diagram shows that the current leads voltage by a phase angle of phi. Okay, now if it is going to be, if the equation is going to be I is equal to Im sine omega t minus phi, we say that the current lags behind the voltage by a phase angle of phi, which means the phase difference between the current and voltage will be phi. So this is explained in this diagram. The explanation is very well given in the textbook. I want you to go through the textbook, children. Okay, so this is about phasor and wave diagram. With this, we are moving on to an AC circuit containing pure resistor. Okay, so this is a resistor which is connected with a AC source whose voltage is V is equal to Vm sine omega t. So this is a resistor. Now there is a current flow in the circuit which is given as I. Now here there will be a potential drop which is given as V suffix R. So VR is the potential drop due to the current flowing through this resistor. So now I am going to determine what is the value of current. What is the value of current from this equation? So I have to start from this equation. V is equal to Vm sine omega t. So let me start with this. So I will write the equation V is equal to Vm sine omega t, which is the voltage instantaneous value of the alternating voltage. Okay, now since a resistor is connected, you have an alternating current I, small I, flowing in the circuit, which produces a voltage drop across R. So the voltage drop across R is given as VR is equal to the current flowing in the circuit is I and the resistance of the resistor is R. Okay, so this is, let me have this as equation 1. Let me have this as equation 2. Okay, now what is the value of current equation? I know the value of current equation as, what is current? I know I is equal to Im sine omega t. So let us have that. Now I am going to compare this equation using Kirchhoff's, combine the equations. Now how I am going to combine here is, I am going to apply Kirchhoff's loop rule. Hope you remember second chapter. We studied about Kirchhoff's loop rule. So what is Kirchhoff's loop rule? It states that the algebraic sum of the potential difference in a closed circuit. Now this is a closed circuit. There is a potential here which is given as V is equal to Vm sine omega t, and here I have a potential drop. Okay, so the sum of the potential differences in a closed circuit is equal to 0. So according to this circuit, I have the equation as V minus VR is equal to 0. Now this is with respect to Kirchhoff's loop rule. Okay, or I can also write as V is equal to VR. Okay, so this is with respect to Kirchhoff's loop rule, right? Now I will substitute the value of V and VR. I have the value of V here as Vm sin omega t. I have VR as I into R. Now this is the potential drop, okay, due to the resistor R, and this is the potential that is given. So here electrons get the energy from this and it moves to the resistor, gives the energy and come back. So the net potential here, it is equal to 0. So I equate this, V is equal to VR. Now substitute for V as Vm sin omega t is equal to I into R. Okay. Now from this I draw the equation for current as I is equal to Vm by R into sin omega t. So this is the equation for current. Okay, so here now what is the current equation? I is equal to, I will write the current equation, I is equal to Im sin omega t. Now this is the equation for current. Now I am going to compare, let me write this as equation 4, compare equation 3 and 4. Okay, so what is the peak value here? This peak value will be equal to, according to this circuit, I can write as Im equal to Vm by R. So I will rearrange this equation as I is equal to Im sin omega t. Is it clear? See here? Are you able to understand? So this is how we'll arrive at the equation for current based on voltage. You have to remember one thing, we have to start with the voltage equation and arrive at the current equation. Now I am going to compare this equation with the first equation. Now with this, in comparison with this is how the phasor diagram for the current and the voltage. There is no phase difference between these two equations as far as this is concerned. Look at this equation and look at the first equation. V is equal to Vm sin omega t, and here I is equal to Im sin omega t, right? Now both, this is the current equation, sorry, this is the voltage equation, this is the current equation. So as far as these two equations are concerned, there is no phase difference between the value of voltage and current. So when you draw a phasor diagram for this, now look at this, this is the phasor diagram. Now OA is the voltage phasor and OB is the current phasor. Since they don't have any phase difference, they are in phase. So this is how the phasor is represented, and here you have the maximum voltage value is at its peak at A and current value is at its peak at B. Okay, so this is how the phasor diagram for the current and voltage. Now here you have OA which talks about Vm sin omega t and OB which talks about Im sin omega t. Is it clear, children? And you have constant, it is rotating in a constant angular frequency. And when you draw the wave diagram for this, since they does not have any phase difference between them, both the voltage and current start initially at 0, that is at the origin, and this is the maximum peak value of voltage and current it at its peak value. Now here you have maximum, here you have negative maximum. So this is how the phasor goes. So you have to conclude stating that it is clear that the applied voltage and the current are in phase with each other in a resistive circuit. As far as a resistive circuit is concerned, when you draw the current and voltage graph, both current and voltage are in phase with each other. They don't have any phase difference. They are in phase with each other. Okay, so that they reach their maxima and minima simultaneously. So which is a maxima here? Here this is a maxima. They reach their maxima simultaneously, and here they reach their minima simultaneously. Okay, and the current is in phase with the voltage. Current in a resistive circuit. In a resistive circuit, current is in phase with voltage. So this is a very important conclusion that you get from this diagram. Is it clear, children? So please go through this concept. I'll be continuing with AC circuit with inductor in my next class. Okay, ma?